Hello, Math 125 fans. Going to do a quick exam, final exam tour. This is a way that I would encourage anyone to start their studying in a course where you have an exam archive. I mean, the fact that we provide an exam archive gives you a huge way to start your studying and see where you're stuck. Okay? So this sort of studying involves first getting kind of a collection of your topics. This is from my lecture notes, my final exam, and you can find a lot of stuff on my materials page. You can go to my old lecture notes. I just printed this off from there, but there's also a final exam review. But you should really already have a sense. You've been doing the work all term of, okay, we got this thing, net change, total change. We got the fundamental theorem of calculus. Just sort of a sense of, okay, I remember what the topics are. And then we're going to run a little test of how we're doing on those topics. So I've pulled up the final exam archive from our department. I'm going to pick a particular year. I've been doing this for all the courses, so I'm going to use the same year. I just picked a random year. So we're going to go to 2018. We're going to click on it, and we're going to try to identify the question. Now we're doing this. I'm not going to work on the problem at all. I'm just going to identify what the question's about. In doing so, I'll get a sense of what they look like and gain some confidence. So here we go. Here's an exam. First page, integration. And you could take notes in a few different ways. Your exam is not going to be identical to old exams, but this is a nice way to test where your holes are, things that you definitely should know. So to me, that very first question is by parts. So we have a winter. That jumps out at me. It's an integral with a log. Gotta know that's by parts. So if you're not there yet, you tuck that away, but you should know immediately how to start here. So you might think about what that would be. The next one jumps out at me. I have a radical, I have an x squared under it. It's a trig substitution. Yes, we might be scared of trig substitution, but it doesn't mean we can't identify what we're going to do right away. If you don't know, don't spend a bunch of time working on it, because what happens is students spend hours and hours working on a problem, and then they're just more frustrated. Or they come to me and they ask about the most obscure questions from the last 20 years. They think, well, if I study that, then I'll be ready. I think that's a wrong perspective. We need to be studying the bread and butter stuff. We need to be spending quite a bit of time flipping through and seeing which ones do we not know how to immediately start. Okay? You're going to maybe encounter one or two questions that are challenging and you're going to fight for credit. But that doesn't mean you should miss the standard stuff because all you've been studying is the hardest things you can find. Hope that makes sense. So then we go to page 2. More integration. This one jumps out at me. It's a partial fraction. So winter 18. And I wouldn't know how to do that. But you might ask yourself, do you know how to do it? Would you know that you have to check if it's reduced? Okay, it is. You'd factor the denominator. All right. Break it up. Next question. This is a simplifying question. So it's really 2 questions in one. But the thing that jumps out at me is the absolute value. So it's a total distance sort of question, which means you have to split it up or think geometrically about it, what it is. But the main thing is you have to split this into 2 problems, simplify, and go through it. So that's probably the one that might get people stuck. But I feel like because you have a lot of time on the final, there's a lot of opportunities there to try a few different things. Okay, then we have an improper integral. So this is winter 18. Do we know why it's improper? Do we know how we'd write it as a limit? Do we know our first step? So right now we're just thinking about what that first step would be. Another improper. So this entire page is improper. So let's write as a limit and integrate. So far we've seen 3 pages of integration. It's not going to guarantee to be like that, but you can get a good sense now that, okay, I got to know my integration. That will help me the most to get a good score. Okay, then we see an area and cutting in half. That's actually a problem from the homework. So it's an area geometric question. So that's this stuff. And we don't always hit all these topics every quarter. This is just getting a sense of, would I know how to set that up? Or would I have just been stuck? Would I have known step 1? Okay, next one. Oh, we got some sort of acceleration problem. But you're going to have to do it as an area. Ooh, how are we going to do that? So that might be when you like file away. But it's something to do with acceleration. And sometimes, because I've paraphrased here, You might say, well, you didn't put that here. Well, okay, so you're looking for things that aren't in your initial list. So acceleration and what I'd call tomato problems are things you need to know. I don't know why I don't have, I guess net change, we can kind of think about that. But acceleration, velocity. And that also goes, when you're reading a review sheet, don't take that as everything. You need to know what you've been doing all term. Sometimes an instructor forgets to put one thing in there. Now, I'm very careful, but you can't, you do need to know all the stuff from the term, the key ideas. Just because it doesn't appear on one review sheet doesn't mean it's the instructor's fault, even though we try as much as possible to warn you about what's on the test. Okay. And we could come back and talk about that. I would find if I did this in class, students would want to talk about that for 20 minutes. But I find that often distracts us from the fundamental things that are more common in the test. So this is why it's good to do this sort of thing first before you get bogged down. An arc length question, okay. Arc length, so we have a winter, 18. And then some sort of an approximation midpoint rule on a table, which might scare us, but it's a midpoint rule problem. So it's an approximation. So we sort of have this too. It's pretty common that you'll have some sort of page that has something and an approximation. This is a volume of revolution. So we have a volume question, winter 18. Would I know how to start that? Would I know that step 1 is to label it as X? Label X, label everything in terms of X, then look at the axis of rotation and work from there. If you need a review on that, I do have videos from earlier in the term that go through many problems like that. One where I just go through one after another, after another, after another, that I called, the video is called Volumes, Volumes, and More Volumes. And so if you've forgotten that, you might need to go back and do a few, okay? But you'd want to be comfortable. What's this about? A definite interval equal to the work required. Oh, it's a work question. We're pumping things out. So we have a work question, winter 18, number 8. We're going to do some labeling. Immediately you should have this plan of attack, this stack of books plan. You're going to label a typical horizontal slice called the height something, y, and then you're going to do force and distance. How much does that slice weigh? How far does it get lifted? So you should have a plan. You wouldn't want to go into the test and have no plan for how to do a work problem. You can see my former video on that. All right, then we get into the more standard questions that are pretty much on all these. This is a separate and solve question and plug in your initial condition. Then we have an applied mixing question. Mix. So you sort of then take stock. We just made it through one exam. We saw that the last 2 pages were this. We know that's coming. We saw that the first 2, actually 3 pages, were integration. And then we saw a mixture of a few other things. That tells me a lot about what I need to study, especially if I didn't know how to start some of those. Let's do it again. Spring 2018, another tour. Integration, this looks like a partial fraction, so spring 2018. And I would have a plan of attack. We're going to factor the denominator and split it up. I wouldn't have to spend time thinking about that or looking on a note sheet. Part B, a trig integral. A fairly standard one, an odd power of sine. Would I immediately know how to start, or would I be spending time putting it on my note sheet, looking on my note sheet? And do I have it on my note sheet? These are the questions I'm asking myself as I'm kind of journaling through this. An improper integral. It's a rational function. It looks like it's an irreducible quadratic on the denominator. So I'm going to complete the square and have to do that. But really, I think of that as a partial fraction problem. So spring 18, question 2a. Oh, never-ending integration by parts. That was probably the hard one for students, but it's an integration by parts. Watch my video on never-ending integration by parts and how to end it, if you want to see how that goes. Then question 3. We're just trying to tour. We're not trying to get stuck. I think stuck on a problem for hours and hours is not going to help you do better on the final. So now we want to look at an arc length. Okay, so this is spring 18, question 3. And then we have position, acceleration. Okay, that's spring 18, question 4. Total distance. So we're going to do this thing with absolute values. We should have a plan for what we do with absolute values. We set the integrand equal to 0 and split it up. We have a volume of revolution I can see. So we have another volume. And this really starts to give me as a student confidence in terms of topics. We have an average value and a fundamental theorem of calculus part 1. You might say, well, I didn't know that. Well, then you make a little note. The moment I saw this X here, I knew that. So we have spring 18, question, what are we on here? 6. Let's keep going. We have an improper. So another improper. How do I know it's an infinite region? Okay, so spring 2018, question 7. We have a work problem. Looks like a scary work problem, but a work problem nonetheless. We know we're going to label a horizontal slice, figure out how far it got lifted and how much it weighs. That's the plan of attack. Watch my video on that if you need to review. But you should immediately be labeling a horizontal slice. We have separable, so now we've hit the end. We should have a sense of what the solutions to these sorts of problems are going to look like. Growth rate, population model question. All right, and you can play the game one more time. About 15 minutes, you can get through 3 exams and get a really good sense of where the holes in your studying are. So then we have a trig integral. This is fall 2018, trig, fall 18. Question 1. We have looks like a partial fraction, but it needs to be reduced first. So that's fall 18, 1b. What else we got? We have something with a rationalizing substitution. I think ultimately that's going to lead to a by parts, but it's a substitution to get started with. We have an improper, but that also looks like a trig sub. Or, excuse me, or you, I think you could do that as one we know. So improper. So I think I'm going to stop writing just so we can go a little faster here. Here we have, what is this? Circle the correct. So then you make a note of 3A is weird. Does that mean I'm going to let it stop me and worry about it for half an hour? No. I'll make a note to come back. I'll just think about it for a second. Oh, I'm integrating from pi to pi. That's just going to be 0. But from pi to pi over 2, is there anything I can say about that function? Is it positive or negative? So there's probably a short answer there, but you could say, all right, this is about thinking about what it is. We're not going to panic, but it's not asking you to compute it. Okay, we have some sort of fundamental theorem of calculus graphical question. We have a center of mass question, so we would need those formulas. That's a pretty common question. I'm surprised we haven't encountered it yet. So don't assume just because it wasn't on those first couple exams it won't be there. But the center of mass question is really just asking you to compute an integral. You might say, well, I don't remember the formula. You could go a few different places. I have review sheets for it. But if you just want to see some basic examples, I have notes here. They explain, but in terms of using it, it's so you can see in a center of mass question, you're computing integrals. It's just another way for us to test you on that. An interesting thing. What I like about center of mass is you can see if your answer is reasonable. An elevator suspended by a cable. Okay, that's a work question. Ooh, cross sections are triangles. That's actually from the homework. It's a cross-sectional area question. That's from the volume section. Another volume question. Differential equation. Apply differential equation. Ooh, an arc length. I don't know why they put that at the end. So there you go. There's a tour of a few exams. I hope you're just getting what I'm trying to sell here, which is don't panic about one particular question. Scan through a few. I think what I'm seeing, which I always tell students, is first off, master this new material. You know that's coming. Second off, master your integration skills. You know that's coming. And that's typically about half the exam. So you already know half the exam. And then you can get a pretty good sense of the other things. Maybe acceleration, velocity, total distance seems to make an appearance a lot. So I would know right away how to deal with integrals involving absolute values. It appears that volumes and or work appears a lot. Again, I'm not telling you what's on the exam. I haven't seen your exam. It appears arc length and or center of mass appears a lot. And so that really gives me comfort in that I know what's there. I definitely don't want to miss those things in my studying. And I don't want to be surprised when I see them on the test. I want to have a plan for how to approach those problems. All right, I hope that's helpful. Give me a like if it is. And if there's a particular thing you'd like to see more of, I do have a ton of resources on these things. So if you go to my playlist, you can find, let me make this bigger. So I may not make a whole bunch of new videos for this course because I have a 125 playlist. Sorry, I find my way through my stuff. I don't know why it's at the bottom. But that has a large collection. Sorry. That has a large collection of videos that will help you. Final exam review part 1, part 2. I worked through 3 old finals. I worked through another old final showing students common errors. There's a lot of stuff there. But none of that replaces you actually doing problems and looking through old finals. So I hope this helps kind of focus and guide your initial studying. All right.